This is problem 610. So we have another RLC circuit, and we're supposed to figure out some values at times t equals 0 and times t equals infinity. So let's take a look at what the circuit looks like at t equals 0 minus. So we've got our voltage source, 24 volts, our resistor, 12 ohms, a capacitor that will be acting as an open circuit, is VC. We have another resistor, it's 8 ohms. And we have an inductor. The inductor will be acting like a short circuit. So at t equals 0 minus, there is no current flowing, there's no path for current to flow. Our voltage source doesn't have a complete path that the current can flow through. And so all of our currents at 0 minus will be 0. So in particular, IL of 0 minus equals 0. And IL of 0 must equal 0 because the current cannot change instantaneously, and so across an inductor, so that has to be 0. Now let's look at our capacitor. If we make this ground, this side of our capacitor is at 24 volts, this side of our capacitor is at 0 volts, and so at time t equals 0, VC of 0 minus, the positive side minus the negative side is 0 minus 24 is negative 24 volts, and therefore VC of 0 is negative 24 volts. Okay, now let's take a look at what it looks like at time t equals 0. We had VC of 0 was minus 24 volts. We had IL of 0 was 0 amps. This was a 12 ohm resistor. See anything else to label? Call this VR of 0. Okay, so immediately after closing the switch, we know VC and IL can't change. They have to be what they were before. Now, if we look at our resistor, it's in parallel with the capacitor. So this side of the capacitor is connected to this side of the resistor, and this side of the capacitor is connected to this side of the resistor. So they're in parallel. So we know that VL of 0, or VC of 0 is what I meant. VC of 0 equals VR of 0. And we know that the voltage across a capacitor can't change, so that has to be negative 24 volts. Okay, well now notice that the inductor is also in parallel with the resistor. So VL of 0 equals VR of 0 equals negative 24 volts. So now we would like to find the current through the capacitor, and the current through the capacitor is going to be the same as the current through the resistor. It's going to go like that, because right at the instant that we turn on the switch, this inductor acts as an open circuit. So no current is going this way. We know that, IL of 0. So we already have that IL is 0, but also that's why. So if we can find the current through the resistor, we've found the current through the capacitor. Well, let's see what our voltages were. We said that VR of 0 is negative 24 volts. So and this was 8 ohms. This resistor is 8 ohms. So the current through our resistor is minus 24 volts over 8 ohms, which equals minus 3 amps. And that has to be the same as the current through our capacitor, so that equals IC of 0 is negative 3 amps. And so let's see, we've gotten IC of 0, VC of 0, IR of 0, VR of 0, IL of 0, and VL of 0, so we got all those. So now we need to go to infinity. And let's see what it's going to look like at infinity. Well, our capacitor will be an open circuit, and our inductor will be a short circuit. And so this short circuit is all the current's going to be here. Nothing's going to go in this direction because that's all open. So we'll have this 24 volts, 12 ohms, and then we have and so all our current is going to go here, so we're not going to have any current over here. And since we don't have any current over here at all, after the capacitor has completely discharged, we will have that the VL at infinity will be 0. VC at infinity will also be 0. Let's call this ground. It doesn't matter, the change across it is 0. And we have IL at infinity, there's no current, is 0. And IR at infinity, again, no current, will be 0.